Hello, everyone. My name is Alex. I represent OxidOS Automotive. Thank you so much for the warm welcome. I'm really happy to see so many people joining the Rust Global and joining this amazing conference. In the following minutes, I would like to talk a little bit about OxidOS, our goal, and feel free to ask questions afterwards and meet me in the lobby to discuss. So our goal at OxidOS is to build a real-time embedded operating system which is modular and can be used in safety-critical environments, mostly automotive. Automotive because it's the industry that needs it most. As Frederick said just before me, the automotive industry is looking at Rust components in the lower levels of the chips, like bootloaders, hypervisors, and usually software that is very critical and runs in privileged environments. OxidOS is one of them. So if you're expecting it to be an infotainment operating system, it's not. It's the small chips. We control the small chips in your cars, which are in the hundreds, that run the engine, open your doors, control your headlights, so on and so forth. In our vision, the automotive industry is switching over to the software-defined vehicle. Software is getting more and more important in the car, and instead of having hundreds of small chips, OEMs, automakers, are trying to consolidate and bring bigger chips in the car, which will perform several functions. If you want an analogy, it's more or less what happened to the grid and cloud in the 2010s. So instead of having small computers distributed, they concentrated into data centers. This is what is happening today in the car. We actually are there in the edge. In our vision, and probably this is shared by most of the OEMs, the car will have several beefy computers which will control several functions in the car. This is the good part. Oh, right. Thank you. The sad part is we still need the small chips, just that the small chips can be smaller and simpler. So even though you will have some beefy computers in your car, every headlight, every door, every single thing that moves in the car will have a chip on it. And this is because the number of cables otherwise is impossible. So these big computers, does it work? Oh, yeah. These big computers control the policy of the car and what it should do, but the actual actuation will be done by small chips. This is where we, OxidOS, try to make a difference. These chips will be probably small, perform a single task, and if they lose communication with the big computer in the car, just put the device into a safe mode. For instance, if the brakes lose connection with the head computer, they just break. So what is OxidOS? OxidOS is an operating system framework based on the open source operating system called TalkOS, which we have been contributing for more than 4 years now. OxidOS is just the commercial version of it. What we're trying to do is to certify the operating system under ISO 26262 standard, the functional safety, and try to do all the paperwork and all the documentation necessary for the ASIL D out of context certification. We fully support RISC-V chips. We support small chips like Codex-M, Codex-R, and recently we have migrated to bigger chips, Codex-A. So we are trying to build the same operating system for the really small chips here and for the big chips, which are these ones here. In the big chips, the operating system should be used as a bootloader or a trusted operating system. So why should you choose OxidOS? Unlike current small operating systems, OxidOS is way more advanced in the sense that the operating system is completely separated from applications. So today, if you want to build these small operating systems, you have to take all the applications, you have to take the operating system, bundle everything into one single binary, certify that, and put it into the car. In our case, you just need to take the operating system, certify it once, put it in the car, and then sideload applications. Applications can be written in anything you want, anything that compiles to binary code, from C to the D language to WASM to Rust. All right. As I said, we have better control for individual applications. You can swap them out, update them, put several versions of the same application into the production. And very, very important, applications can never crash the OS. So in typical small operating systems, if an application does something which it shouldn't do, usually the operating system crashes. This is not the case here. So applications work like if they were Linux applications. They just fault and can be restarted at any time. The operating system is fully written in Rust with no single line of C code. This is a slide that is not necessarily for this conference. We chose Rust for the operating system because it gives us some advantages and some safety guarantees, but it turns out that people are really productive when using Rust, and we have seen this in production as well. We do have a cybersecurity focus, meaning that applications are completely isolated from the kernel. Applications are firewalled, so let me give you an example. We had a customer which had a beefier chip, let's say a larger chip. The chip was doing its normal job, but they had spare cycles and wanted to open these cycles up for other development teams within the company. So the use case that they found for OxidOS was add OxidOS, build an application that performs the actual job of the chip, and then allow other teams to sideload applications which would just use the cycles. The important thing is applications were digitally signed. Based on the digital signature, the operating system would allow the normal application, let's say the purposed application, to perform the function of the chip, while other teams had a different signing key. Those applications were not really allowed to interfere with whatever the chip was doing normally. They could use all the other resources that were not critical for the chip. So this was one of the use cases. And this is not possible in current operating systems for the small chips. What do we offer? So we offer the operating system, binary and source code. This is really important because I get this question really, really often, like, do you have the source code as well? Of course, because you need to certify it. I mean, we give you all the certification paperwork, but it's out of context. You need to add it to the hardware and certify it. It's fully compatible with OS, so we try to be as close as possible to the upstream, and technically, if we ever cease to exist, the knowledge will be out in the open source community to actually maintain it. We do have an online simulator which we can access online, which simulates the operating system and runs the real binaries that you would load on the chip. You could use it online. We offer the full certification documentation. We will offer as soon as the ecosystem helps us, and we are one of the members of the Rust Foundation's Safety Critical Consortium and pushing to make the ecosystem work faster with us, and we also offer the support for the hardware bring-up. In terms of our roadmap, we have seen in 2022 that several companies, including automotive companies, are looking seriously at Rust. In 2023, we have many we had compiler vendors already which offer compilers. We had chip manufacturers which were experimenting with Rust, and we have development tools developing really, really fast. In 2024, OEMs are starting to think to add alternatives to AutoSAR. AutoSAR was the default standard for small chips. OEMs are starting to search for alternatives. We hope that in 2026 we can have a stack which is more or less compatible to what AutoSAR does, not binary compatible to it. And we hope that we can have reach certification in 2026 together with the ecosystem and everything that we have. This might seem a long timeline, but look at the automotive software development. Cycles are super long. Our expectation is that somewhere in 2030, this can be used at full scale in cars in production. I think we are the most advanced in the certification subject. We are as far as possible at the edge with certification, but we are still waiting and working with the ecosystem to make it happen. So yeah, this is about OxidOS. Thank you so much for listening out, and if you have any questions, I'll be happy to answer.